Hey there, my name is Bart. I'm a professor at the Catholic University of Leuven in Belgium and a lecturer at the University of Southampton in the United Kingdom. I was asked to say a few words about research in data science. I think research in data science focuses too much on the algorithmic component. I think more focus should be put on other aspects, such as data, for example. Data is the key ingredient to any analytical model, and it's very important that the data is of good quality. Closely connected to this is the issue of feature engineering. In feature engineering, the idea is to come up with new data elements, we call them features, in a very creative way. And we can think of various types of features. Think about the whole research stream on social network analytics. Basically, in social network analytics, what we do is we build a network of entities, connect them through various links, and then featureize the network as variables into a traditional analytical model. Obviously, a social network can be featureized in various ways. Hence, it is important to carefully think about how you're going to featureize a social network. Are you going to look at social network metrics such as closeness, betweenness? Are you going to try and detect communities and come up with features measuring community characteristics, etc.? So using the idea of social networks from a feature engineering perspective is a very important activity to basically boost the performance of your analytical models. Besides social networks, also time is very important. Typically, analytical models are built using a snapshot in time. But obviously, the environment is subject to continuous change, endogenous effects, exogenous effects, etc. So it is very important to also look at how information and how features are going to change in time, whether there's a time decay that we should take into account and so on. Also, this presents some very exciting challenges from a research perspective. Besides the key ingredient of any analytical model, data, we should also have a closer look at the analytical models themselves. Far too often, these analytical models are being developed by optimizing a statistical objective function. When we say statistical objective function, you can think of a likelihood function, mean squared error, cross entropy, and so on. But when you really want to bridge the gap of analytics as a theoretical discipline and analytics as a business enabler creating new competitive advantages, then other criteria are important as well. We need to make analytical models more and more business focused. That means that we should focus on, for example, profit. How can you quantify profit in a churn setting, in a credit scoring setting, or in a fraud analytics setting? And how can you come up with profit-based measures which are going to gauge the impact of an analytical model in a business relevant way? Once we have those profit measures clearly defined, we can use them in two possible ways. We can use them first to evaluate our analytical models, but even more interesting would be to directly embed those profit-based measures in the estimation process of the analytical models themselves, such that the coefficients of a logistic regression or a linear regression model are no longer optimized by maximizing a maximum likelihood or any kind of other objective function, but are now being optimized by maximizing profit, for example. Besides putting the right business focus in terms of profit, for example, we should also carefully look at the interpretability of our analytical models. The impact of analytical models is now bigger than ever before. Think about all kinds of regulatory guidelines such as Basel and solvency, which have clearly amplified the importance of analytical models. Building analytical models should also be done by taking into account interpretability of these models. Given the crucial impact of these models, interpretability is a key concern. Hence, in many settings, we are not interested in coming up with a black box neural network or support vector machine or random forest-based model, but we are interested in having simple to explain models that allow us to give us some very simple insights into our underlying business processes. Next is obviously, as I already mentioned, the whole issue of regulatory compliance. Regulation is getting more and more complex. Think about privacy regulation, think about ethics guidelines, and so on. So it is important that our analytical models always respect these guidelines. Finally, we also have the operational efficiency. Operational efficiency entails the efforts that are needed to set up the analytical model, to run it, and also to backtest or monitor it. In online scoring environments such as fraud detection, these are very important requirements. To summarize, I think research in data science should focus a bit more on the data part from a feature engineering perspective by being really creative on how you can define features like social network features, time-based features, other types of features, etc. I think research in data science from the analytics perspective should focus more on developing analytical techniques that optimize business criteria, such as profit. And I think that analytical techniques should also focus more on coming up with interpretable and operationally efficient models.